Today I'm going to be discussing with you 6.6 and 6.7. 6.6 is approximating the binomial with a normal. Why would you want to approximate the binomial with a normal curve? The reason why is sometimes the combinatorics in a binomial become too large and you cannot do them with a computer. Also, you may have to do several hundred different probabilities and sum them together, and that just becomes not feasible anymore after a certain point. If you look on page 313 in the orange box, you will see the requirements. The requirements for approximating a binomial with the normal curve are n times p is greater than or equal to 5, and n times q is also greater than or equal to 5. We use the mean from the binomial, which the mean from a binomial is n times p. We also use the standard deviation of a binomial, which is the square root of n, p, and q. So those become our new mean and our new standard deviation sigma. One very, very important thing to remember is when you use your z-score formula, it is x minus mu divided by sigma. Do not divide by the square root of n. Again, do not divide by the square root of n. That is the formula that you're going to be using. Also, you have to be very careful and worry about the continuity corrections factor, because you are approximating a discrete distribution with a normal. So you might have a 0.5 in either direction. You have to be very, very careful with that, though. There are some examples on page 316 on the left-hand side of your textbook. There's several graphs to look at, and they talk about when you have to add the 0.5 and to which side. So be very, very careful, and remember your continuity corrections factor. 6.7 deals with assessing normality. A lot of times when we work with data, it has to be normal. How do we determine if it's normal? Well, we can look at a histogram. We can also look at what's called a normal probability plot. And if the normal probability plot makes a straight line, the data is fairly normal. If it makes some type of curve, a statistician would look at that and try to fit a different curve to it, a different type of model. This is very important in higher level statistics. In this course, we deal with data that's already normalized. However, if you take more advanced courses, you may work with data that's not normalized, and you may have to normalize it by taking a log or fitting some sort of cubic spline or something similar to that. So if you work with data that's not normal, you would have to transform it. However, in this course, we work with data that is. But I just want you to see what is normal and what is not, and you can again look at that by making a histogram, and it should make a bell-shaped curve, or looking at your normal probability plot and making sure that it makes a straight line.